Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. In this video, we'll be covering circles. A circle is a closed shape in which a set of points are at equal distance from a particular point. So that particular point is called as the center of the circle, and that equal distance is called as the radius of the circle. Okay, so radius is the distance between the center of the circle and any point on the circle. Okay, now we'll look at few elements of circle. The first thing that we'll look at is a chord. Chord is a line that connects any 2 points on the circle. Okay, diameter is the longest chord of the circle. The diameter passes through the center of the circle. Okay, and diameter is equal to twice of radius. So diameter is equal to 2 into radius. Then we look at tangent. Tangent is a line that touches the circle at exactly 1 point. Okay. Now we will look at few things related to chords. So the first thing is equal chords are equidistant from the center and vice versa. Okay. What it means is if AB is equal to CD, AB is a chord and CD is also a chord here. So if AB is equal to CD, then OE equal to OF. OE is the distance of AB from the center and OF is the distance of CD from the center. Okay, and vice versa is also true. It means if I have been given OE is equal to OF, then AB is equal to CD. Okay. The second thing is perpendicular dropped from the center of the circle on a chord bisects the chord. Okay. What it means is in the figure angle AEO is equal to angle BEO is equal to 90 degrees. Similarly, angle CFO is equal to angle DFO is equal to 90 degrees. Also, point E is the midpoint of AB. That means AE equal to EB, and point F is the midpoint of CD. That means CF equal to DF. Okay, these are the few properties related to chords. Now we'll look at arcs of a circle. Arc is actually a portion of the circle, portion of the circumference of the circle to be precise. So major arc is an arc that is longer than the semicircle. So if I look at arc ADC here, ADC is a major arc. Okay, minor arc is an arc that is shorter than the semicircle. So ABC arc over here is shorter than the semicircle. So arc ABC is a minor arc. Okay. Now circumference of a circle is the length of the arc that creates the circle, and area of the circle is the area enclosed by the circle. The formula for circumference and area is circumference is equal to 2 into pi into radius, which is equal to pi into diameter also. The area of a circle is pi into radius square, where pi is equal to 22 by 7 or almost equal to 3.14. Now the question over here asks us to find the circumference and area of a circle with radius 100 centimeter. So radius has 100 centimeter. That means r is equal to 100 centimeter over here. Circumference is equal to 2 pi r, which is 2 into 3.14 into 100, which is 628 centimeter. That is the circumference. Area is pi r square. That means 3.14 into 100 into 100. That means it is 31,400 centimeter square, the area. Now over here we'll look at what is a sector and what is a segment. Sector is a slice of the circle formed by two radius lines, as you can see over here. Okay, and segment is a part of the circle formed by the chord of the circle. Okay. Now we look at major sector, minor sector. Basically, major sector is a sector that is more than the semicircle, as shown over here. Minor sector is a sector that is smaller than the semicircle. Okay. Then we'll look at major segment and minor segment. Again, major segment is a segment which is more than the semicircle, and minor segment is the segment that is smaller than the semicircle, as shown here. Okay. Now we will look at the area of a sector and the length of arc in a sector. So over here, a sector with central angle theta is shown. That means angle AOB is theta. Okay, and the radius of the circle is r. So area of sector OACBO, which is the minor sector over here with central angle theta, is given by pi r square into theta by 360. Okay, pi r square is the area of the entire circle, but the area of sector with angle theta is given as pi r square into theta by 360. Okay, the length of arc ACB is given by 2 pi r into theta by 360 similarly. Okay, so circumference is 2 pi r, but the length of arc ACB is 2 pi r into theta by 360. Okay, now we'll do few properties of circle. So the angle formed at the center of the sector is double the angle formed in the alternate sector, and the angles formed in the alternate sector are equal. What this property actually means is that in this figure, if you see, O is the center of the circle. So AB are 2 points. If they form angle 2 theta at the center, then in the major sector ADEB, in that sector, the angle formed will be theta, half of the central angle. Okay, so if angle AOB is 2 theta, then any angle made in that sector will be theta. That means angle AEB is theta and angle ADB is theta. Okay, so what that means two things, that angle ADB is equal to angle AEB. Also it means is that angle ADB is half of angle AOB. Okay, this is what this theorem means. Okay, so now what we'll look at is about tangents of a circle. So for a given circle, two tangents can be drawn from a given point outside the circle. Okay, over here we are shown two tangents PT and PT dash from a point P. Okay, the property related to tangents is that the tangent are equal in length. So that means PT is equal to PT dash. Okay, now this last property that we need to do for circles is that the angle subtended in a semicircle by the diameter is a right angle. What it means is, over here AC is the diameter, then the angle subtended by the diameter on any point on the circle will be 90 degrees. So that means angle ABC is always equal to 90 degree. Okay, because AC is the diameter. Okay, so this is about the properties of circles. Thanks a lot for watching this video.